7 of programming with C++, week 7 of programming with C++. Now, today our main focus will be on functions. Our main focus will be on functions. So let's get right to it. So what are functions? Functions are blocks of code that perform specific tasks. They are blocks of code that perform specific tasks, and um, the main reasons why we use functions are for modularity, readability, and making uh, programs easier to manage and read. That easier to manage. That is readability, and then also program reusability. So we use functions for usability. We can write the code once and use it multiple times. For modularity, it breaks the complex problems into manageable units. And then I've explained readability. Also for easier debugging, since problems generated will be isolated to specific functions. So these are the reasons why we use functions. Now let's move on to type of functions. So the type of functions, we have user defined functions, and these are created by the programmers to perform a specific task. And also we have the standard library functions. These are already predefined functions available in the C++ libraries. Examples are the std, double, colon, cout, and the rest. We have virtual functions as well, and they are used in inheritance for polymorphism. We've done inheritance, we've done polymorphism. So I believe you understand what I'm saying. And then inline functions. They are small functions where the compiler replaces the call with the function's code for performance. So over here, the compiler replaces the call when you are calling the function. It replaces it with the function's code for performance. So these are the types of functions that we have. Now let's move on to done the benefits already. So let's move on to function declaration. Function declaration. So for function declaration, the declaration or a function declaration tells the compiler about a function's name, the parameter, and then the return type. The name, the parameter, and the return type. So let's look at the syntax of a function declaration. So the syntax is basically the return type. The return type is like the data type of the function, right? So the return type is also known as the data type. So in this case, int, char, boolean thing, right? And then the function name, that is the name of the function. And then the parameters, parameter one, parameter two. So let's go on ahead to look at this example over here. So over here, a function has been declared. What's the name of the function? Find sum. What is the return type? Int. What are the parameters? Int first num, int second num. So that is the basic syntax of the function declaration. So let's put that into use in our code blocks. Let's see if we can also declare a function. So first of all, the function is declared in the global scope, right? The global scope that is outside the local scope. So we first declare the function outside or in the global scope or within the global scope. So the syntax was our return type. That is our data type. So in this case, int, then our function name. So that sum will be the name of our function, and then the brackets. Then within the brackets, you have your parameters. So in this case, we are finding the sum, or we are getting the sum of two variables, that is a and b. So int a comma int b. Then we would terminate it. So by doing this, we've declared a function. The function is called getSum, right? Then the return type of that function is int, and our parameters are int a, int b. So we declared a function. Now let's move on to this over here. The person called out the function, but we've not gotten to function calling yet. So I wouldn't want us to rush there. So let's move on to function definition. Function definition. Now, what is function definition? So function definition over here, the function definition provides the actual implementation. So this is where you are now going to add certain things to the declaration, right? For example, the function body. So within the function body, you would have the line of code that would be executed. Okay, that will be executed, and once you call the function out, right, the line of code that will be executed. That is where, or that is what will be in the function body, as well as the return value, the return value of the function, and then of course they will be enclosed in curly braces. They will be enclosed in curly braces. So basically, these are statements within the function, but that is the function definition. So the function definition will comprise of the function body and the statements to perform the task, and then the return value. But note that if the return type is void, then no value will be returned. Or let me rephrase it. A value will be returned, okay, as long as the return type is not void. Yes. So that is the function definition, right? So as I said, it is the same syntax, right? Your return type, your function name, your parameter list, right? The over here it can be optional. The parameter list can be optional since you'll be introducing arguments. We'll get to arguments soon. So and then the body will be enclosed in curly braces as I mentioned earlier on. So this is the basic structure you can see over here. That is it, the basic structure. Okay. So let's move on. So I've already explained what the return type is, the function name. I don't have to say that again. The parameters too, we've seen what they are. The function body and the return statements are new. So let's go on ahead to demonstrate that in our code blocks. So let's all right. So we declared a function over here, right? So let's go on ahead to define the function that we declared. So we do that by introducing our curly braces. Then within the functions body, we provide um, a statement, right? That would be executed once you call the function. Okay, so in this case, we are adding two numbers and two numbers, right? So int a, int b. So we can first assign values for int a and int b. No, okay, we don't really have to assign values to int a and int b here. Yes, but what you can do is you can tell the system what it should do with a and b once we call it in the local scope. So since we are adding int a and int b, then we can go on ahead to say int sum because we are adding. Then our assignment operator or equal to a plus b, right? So over here within the functions body, we've made it clear that now once we call out get sum, okay, and we assign values to get sum, okay, those values assigned, okay, should represent a and b, and they should be added, right, and they should be stored in sum, right. A memory space should be allocated for sum, and sum will store the results of a plus b, right. Then we go now, then we go down to give the return value, right. So over here return sum, then we terminate, right. So that is function declaration. So we can also verify from this example over here. So over here int, let me highlight this so that it's easier to see what I'm talking about. Can I highlight? Let me see. uh, it seems I cannot highlight, so let me just use the mouse pointer to pass on it. So over here, int add first num, int first num, int second num, right? So for the parameters, they also have their data types as well. So that is what you did in our case. You used emp, then the function body. So int result is equal to first num plus second num return results, right? Since they use the results over here, that's why they choose to use the, or that's why they use return results, but we use sum. So ours is return sum. Okay, so that is it for the function definition. Now let's move on to the parameters. So the parameters, what are function parameters? So they are variables in the function definition that receive values. Variables in the function definition that receive values. Now let's take note of what um the definition I just gave, right? The variables in the function definition. So the parameters are basically focused on the function definition, right? So they receive values in the function definition. They receive values in the function definition. Okay, and then okay, let's look at the syntax. So the return type, the name of the function, type one name one, type two name two. Type one means data type, and then the name, data type, and then the name. So we've seen how um it works. The parameters. So this is a parameter, the int first now. Let me even show you here. These are parameters. Okay, these are parameters. They receive values. They receive values. Okay, they receive values. So when you are calling out them in the function definition, okay, these are the parameters. So when you are calling them out, okay, and you assign a value, right? So we get to function calling all, but I'm just trying to uh, you know further explain this thing very well. So when you are calling out the function, okay, once you assign values to the get some function, then what you've done is that since you've already introduced parameters in the function definition, you will receive those values. You will receive those values. So A and B will now receive those values you've assigned when you were calling it out in the local scope, right? And then the values itself you are assigning to the get some function, the value itself you are assigning to the get some function is called the argument. So let's quickly look at that. Okay, so the arguments are the actual values passed to a function when it is called, right? So during a function calling, when you are calling out the function that you've defined in the global scope, right? Let's say in this case, get some. So when I call out get some and I say, okay, get some 1 comma 2, right? What of the 1 comma 2 that I have passed to the function is called an argument, right? It's called an argument. Whereas the parameters was, or the parameter was already defined in the function definition as int A, int B. So they will now receive those values I have assigned to the get some function when I was calling it out or when I called it out. Okay, so that's the difference between the parameter and then the argument. Okay, parameters uh, they receive values in the function definition, and then arguments pass, or they are the actual values passed to a function when it is called or when it's being called. Okay, so let me quickly give an example to you know very like clarify everything. Let me give an example to clarify everything. So I won't give an example for the parameters because I've already done one here. This is a parameter, but let me give you one for the argument. So now the argument would be within the local scope, right? So we can have right now I'm calling get some function. So you can see uh, get some, get some, then I'll bring my brackets, right? Then 1 comma 2. So these values I have assigned to the get sum. Okay, these values I have assigned to the get sum are called the arguments, right? They are called the arguments, right? So what this line of code means is that now in the function definition where a and b, okay, are integer data types, right? What is happening here is that now we've assigned values to the get sum function, that is 1 and 2. That is our argument. That the argument is 1 comma 2. So now this one means a is now 1, b is now 2. Okay, a is now 1, b is now 2. So the parameters will receive the values in the function definition. Okay, they will now receive the values in the function definition. Okay, and then the line of code we, or the function body where we, made statements to define what the function, or define what action the function should execute once the values are provided. Okay, it will now come and follow that. So when we go out or when we want to display our get sum, okay, we want to display our get sum, the result of our get sum over here, it should follow this syntax over here, right? So it will add the 1 and 2, which is the a and b. It will add it, store the value in sum, and then display the value or display the result. So that's basically how the functions, or how functions work. Okay, so let's move on. So we have other arguments, so references as arguments, pointers as arguments, arrays as arguments. Then let's move on to default arguments. Default arguments. So they are actual values assigned to parameters during function definition or declaration. Actual values assigned to parameters during function definition or declaration, right? So over here, this is the syntax. Okay, our return type, as usual, the name of the function, the type, or okay, our parameters. But in this case, we assign a value to one of the parameters, and then it's always the ending parameter. The value is assigned to the ending parameter, and the ending parameter here, the ending one. So let me see. Okay, so there's a clear example over here. So int get some int x, int y is equal to 20. The value is always assigned to the last parameter. Okay, the last one. So that's where you assign the value. Okay, so that's a default argument, right? So in this case, should you only assign one value, okay, to get some, when you call it out, should you only assign one value, it will add to the 20 that's already defined in the function definition. Okay, and then your value or your result will be 25. Okay, so let me show you that over here. So let's say in this case I use a default argument. So I assign 25 to b, right? So when I do this, and then I am calling the function out, and then I only bring one number, that is 1. Okay, what will happen is that when I instruct the console to display the answer for me, my answer will be 26, because I already defined or assigned a default argument within the parameter in the global scope or in the function definition. So that value will be stored there, and now the one will go and add to that value 25, that is already the default argument, or I have already assigned initially to the parameter, and then the value will now become 26. The sum will now become 26, right? And then also, bring two values if I should bring two values, it will now overwrite this 25, right? It will now kind of replace it. Yes, it will replace the 25. So now A will be 1, B will be 2, not 25. Okay, A will be 1, B will be 2, and not 25. Because I've assigned two values. So it will overwrite the default argument. It will overwrite it. Then it will be replaced by the number I bring, the certain number I bring when I'm calling out the function, right? When I'm introducing the argument to override the default argument in the parameter. So in this case, I wrote 2 or I typed 2. So now 2 will come and replace the 25, right? And then A will be 1. So if I'm to display the result for this, my answer will be 3 and not any other number. Okay, so that is how the default argument works. So let me see. Yeah, so that is their example as well, or that is an example here as well. So any one which you are comfortable with, you can also take that. So default arguments. Okay, now let's move on to function calling. Now defined, we've declared our function, we've defined our function. How at all can we call the function? Right? We can't, define a function without calling it. We will call it. That's why we were defining it in the first place. So let's look at how we call functions. So this is the syntax, right? So a function name is very simple. A function name, and then your arguments. That is it. Your function name, your arguments, your function name, your arguments. So let's call out a function. Okay. In this case, let's just maintain this, right? Now I'll call this function out, right? But I want to display. I want to display the results, right? So to do that, we just have to see out then. So let's see if this code is correct. 3. Okay. So as I was saying, this is how we call functions. This is how you call functions. Now, what I did was I called the function, then I called the function, and then I displayed what the return value of the function is, right? I display what the return value of the function, which is 3. Okay, but you can decide to call the function without displaying the answer. That is your own decision. But basically, this is how you call functions, right? So the syntax is simple. The name of the function, right? The name of the function you know give to the function, and then your arguments, and then that's it. If you want to display it, then you do your cout, right? So that is function calling. That's function calling. Now let's move on to function overloading. Now the function overloading, um, and mind you, let me make this point. Um, the fact that I'm using only int doesn't mean that, or the fact that I'm using int doesn't mean that functions only take integer data types. They take any data type, but in this case, I'm using int. Okay, I'm using int for my explanation. Could have used string, I could have used bool, char, any other data type. I'm using int, the data type. So I don't think functions only accept int data types. No. So function overloading, right? So function overloading can be done in 3 ways, right? So let's first look at what it is. So function overloading is basically defining multiple functions with the same name but different parameters. So they have the same name. So you can have the get sum function. You can have it 3 times, you can have it 4 times, you can have it 5 times, but they have different parameters, right? Their parameters are not the same. Once their parameters are the same, then what you've done is not function overloading. What you've done is a big error. So um let's look at the various ways you can overload the function, right? So we can do it by having different number of parameters, right? Different number of parameters. That is, you can have a get some the get some function. You can have it to two parameters, and you come down, do the same get some function, but in this case with three parameters. You can come down, do the get some function, but in this case with four parameters. So let me demonstrate the first scenario with different number of parameters. So um, you see, this is our get some function over here, right? Now over here it has two parameters, that's int a, int b, right? Now I can come down here and do the same get some function, right? Same get some function. In this case, with three parameters, int a, int b, int c. Okay, then I can also choose to, define it. Maybe int sum, then equal to a plus b plus c, right? Can just do this. So what I've done here is that I have done function overloading. Okay, the same function get some, but in the first function the parameters are two, in the second function the parameters are three. So that's what I've done. Okay, that's what I've done. That's what I've done. That's what I've done. So that is the first case scenario where you can have a different number of parameters. Now let's look at the second case scenario by having different types of parameters. Different types. So mind you, we are looking at different number, different types. Okay, and both different number and types. So let's go ahead and look at the different types. So for different types, that means that the data type, okay, the data type of the function will not be the same, okay. So you can see, okay, this was case one. So we've done case one already. You can see case one over here. Okay, now case two is also over here, right? So as I was saying, different data type but the same function, right? It is still an add function, add, but here the data type we used was int, here the data type used was double. So let's go on ahead to also showcase the case two, right? So we can just quickly modify this. So let's maintain the first one, and then let's modify the second one. So in this case, int a, int b, right? Then we change the data type, so double. Can also change it to float, okay, and all that. But let's use floats. Float. Then we also change this one also float. Can also change this one as well float. Okay. Ah, yeah. Okay. So what we've done here is that we have used different types or different data types in the same function. With the same function. So initially our get some function had an int data type. Then the second get some function has a float data type, right? So just as how we saw in the example. Then case three is a combination of the two. Case three is a combination of the two. So let's also look at that combination of the two. So meaning we can have uh, different types and numbers. Yes, we can have different types and numbers. So in this case, let's go on ahead to add one more over here with C, right? With C. So this is a combination of the two, right? So combination of different types and numbers. So over here, our parameters are three, Over here, our parameters are 2. Over here, our data type for the parameter and the function are both int or integer data types. And then over here, the data type for this function is float, but they are still the same function. Okay, they still the get sum function, and then the other one is also a get sum function. So in doing what you just did, we've overloaded the function, or we've done what you call function overloading. Function overloading. So that is it for week 7. That is it for week 7. So look forward to week 8.